Let's write the balanced net ionic equation for NaOH plus NH4Br. This is sodium hydroxide and ammonium bromide. The first thing we need to do when we balance net ionic equations, we need to balance the molecular equation. And this is the molecular equation. It's already balanced, so that's kind of nice. Next, we'll write the state for each substance. That'll look like this. If you know your solubility rules, compounds with sodium, they're very soluble, and compounds with the ammonium ion, very soluble. So all of these have aqueous written after them. They're soluble, they'll dissociate into their ions. Ammonia, we could write aqueous. It will dissolve in water. It won't split apart into its ions, but we could write aqueous or we could write gas. So let's go with gas. It really won't change our net ionic equation that much in the end. Water, that's a liquid. Now we'll split the strong electrolytes into their ions for the complete ionic equation. That looks like this. So this is the complete ionic equation for NaOH plus NH4Br. You'll note that the NH3, we kept that together. We don't split gases or liquids apart in net ionic equations. If this was aqueous, we wouldn't split it apart either because NH3, that's a weak electrolyte. We call it a weak base. So we wouldn't split it apart if it was aqueous either. So it doesn't really change a lot. Now we can cross out the spectator ions. They're on both sides. So in the reactants, I see this sodium ion here, and in the products, I have it again. That's a spectator ion. We're going to cross that out. There's the bromide ion, Br minus, again in the products. Spectator ion gets crossed out. But what's left, that's our net ionic equation for sodium hydroxide plus ammonium bromide. I'll clean this up, write the states. We'll have our net ionic equation. So this is the balanced net ionic equation for NaOH plus NH4Br. You'll note charge is conserved. We have a plus and a minus. That gives us a net charge of 0. Over here, everything's neutral. Net charge of 0. If you count the atoms up, they're balanced as well. Note again that this NH3, if we had it aqueous here, we would just have aqueous written here for the NH3 in our final net ionic equation. This is Dr. B, and thanks for watching.